Alright, welcome to tonight's video on curve sketching part 2. This is going to include curve sketching when you have oblique asymptotes. Oblique asymptotes occur only when there is no horizontal asymptote. So how do we find oblique asymptotes? We are going to use polynomial long division to find them. For example, here notice the degree of the degree of the numerator would be 3. The degree of the denominator would be 1. So notice there is no horizontal asymptote because the numerator is larger than the denominator. So there is going to be an oblique. To find it, we're going to do long division. So remember the rules of long division from last year in Algebra 2. The first thing you do is you divide x to the third by x. And you get x squared, so that's the term that goes up here. Then you multiply x squared times x minus 1 gives you x to the third. X squared minus 1 gives you x squared. Then remember you subtract. The first terms cancel out. Negative 6 minus negative 1. So negative 6 minus negative 1 gives you a negative 5x squared. Then you bring down the 8x. Then you do the same thing again. You go negative 5x squared divided by x. And you get negative 5x. So then you multiply, so you get negative 5x squared plus 5x, subtract, and then when you subtract down you get 3x minus 3, and then 3x divided by x gives you 3. And then when you multiply 3 times negative 1, you get negative 3. Subtract, and notice you get the remainder of 0 here. So basically, here, your answer is x squared minus 5x plus 3. So that would be the oblique asymptote in this equation. So now that we know how to do long division, let's do a simpler one where we'll actually draw an oblique asymptote. So remember, step 1, we're going to factor. So here the function is going to equal x plus 3 over x minus 2 over x plus 2. Then that allows us to tell what the vertical asymptotes are. Well, in this case, there's only one. Vertical asymptote is x equals negative 2. Horizontal asymptote, there is none because the degree of the top is bigger than the degree of the bottom. An oblique asymptote, well, here we're going to have to divide. So we go x plus 2 over x squared plus x minus 6. We divide, so x squared, x goes into x squared x times, then we multiply, x times x is x squared, x times 2 is 2x, then you subtract, 1 minus 2 is negative 1, then you bring down the 6, then you divide again, so negative x, how many times does x go into negative x? It is negative 1. You multiply. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. Then you subtract. Negative 6 minus negative 2 gives you negative 4. It doesn't matter what your remainder is. The remainder is insignificant. This here is your oblique asymptote. So your oblique asymptote is y equals x minus 1, that line. So if you were to draw just the asymptotes, you have a vertical asymptote at x equals -2. You have an oblique asymptote of the line y equals x minus 1. So remember, you start at -1, and you would go up 1 over 1 to draw. So basically the line y equals x minus 1, that is your oblique asymptote. Okay, so now after that we can determine if the oblique asymptote is crossed, because remember, we'll take the x minus 1 and we'll substitute it in for y to see, is the oblique asymptote ever crossed? So we put it into the function for the y value. The top is x squared plus x minus 6 over x plus 2. Then remember, we're going to multiply to get rid of the denominator. So then when we FOIL here, we have x squared plus 2x, actually plus 2x minus x minus 2 equals x squared plus x minus 6. Combine like terms. And notice when we subtract, notice these go away. So you're left with -2 equals -6. That is no solution, meaning the oblique asymptote is never crossed. All right, so now we can do the x-intercept by putting 0 in for, remember, x-intercept, you set the numerator equal to 0 as a factor. That's x plus 3 and x minus 2. So that means x equals -3, x equals 2. So our x-intercepts are -3, 0, and 2, 0. Those are our x-intercepts. So here's so here's 2, 0, and as you can tell, I moved the asymptote to -2 because I mistakenly put it at +2. So hopefully you corrected that. So there's 2, 0. -3, 0 is right here. All right. So you will notice there are two parts to this graph. There's one to the left of the vertical asymptote and one to the right. Since the oblique asymptote is never touched, you know that the graph is going to go close to it but never touch it. And it's also going to go close to it this way and never touch it. Here, same thing. It's going to go down through the point and to the asymptote in that direction as well. So there's your graph of this function. There's no need to find any additional points. You can find the y-intercept, because remember the y-intercept, you set x equal to 0. So it's -6 over 2, which is -3. So the y-intercept is 0, -3, which would be right about here. So if we want to draw our graph correctly, you can just go like that. All right, so let's do one more. This one, you're factoring the sum and difference of two cubes. Remember, a to the third plus b to the third. When you factor it, you get a plus b times a squared minus ab plus b squared. When you go subtract the difference of two cubes, you get a minus b, and then a squared plus ab plus b squared. So the form is always the same, whether you're doing the sum or difference of two cubes. The first sign is always the same sign as what you started with. Then it's always the opposite sign, and then positive. So this is something that you have to remember from Algebra 2, how to factor the sum and difference of two cubes. So here, for example, x to the third minus 1. Your a term is x, your b term is 1. So when you factor it, you get x minus 1 times x squared plus x plus 1 over x minus 2 times x plus 2. Alright, so your vertical asymptotes at x equals 2 and x equals negative 2. So we can put those in right here at 2, sorry, at negative 2 and at 2. Our horizontal asymptote, well, there is none, because the degree of the numerator is larger than the degree of the denominator. Our oblique asymptote, we have x squared. Now, remember, if it goes from x squared to just the number, we're going to put a 0 in as a placeholder. Same thing here. We're going to put a 0 in as the placeholder for the squared term and the x term. So x to the third divided by x squared gives you x. When you multiply, you get x to the third plus 0x squared minus 4x. Subtract. These cancel out. 0 minus a negative 4 is a positive 4. Bring down the 1. Now notice you can't divide these because x squared has a larger degree than x, so therefore our oblique asymptote is just y equals x, the line. So that means you start at 0, 0, you go up 1 over 1. So it just goes, it's a diagonal line. Like that. Alright, that's our oblique asymptote. Then remember, x-intercept. Remember, you set the top equal to 0. Well, there are two places it could equal 0, x minus 1 and x squared plus x plus 1. Well, x equals 1 here. However, x squared plus x plus 1 equals 0. Well, that is not factorable, so what you would have to do is the quadratic formula to see what the zeros are there. So b squared is 1 minus 4ac all over 2a. And you'll notice that you get the square root of negative 3, which means there's no solution there. So there's only one x-intercept of 1, 0. Right there. Now, the y-intercept, remember you put 0 in for x. So 0 to the third minus 1 over 0 squared minus 4. So you get positive 1/4. So positive 1/4 is above there. It's a little hard to do it. The graph is kind of small. Now you want to determine if the oblique asymptote is crossed. So you set x equal to x to the third minus 1 over x squared minus 4. And you multiply. So you get x to the third minus 4x equals x to the third minus 1. Well, the x's cancel out, the x to the thirds, so you're left with negative 4x equals negative 1, and x equals 1/4. Okay. So that means that at x equals 1/4, that is where the vertical asymptote is crossed. So basically, since the line is 1/4, 1/4, that means at y equals x, that means at 1/4, 1/4, it is crossed. Right here. All right. So what that means is when you graph this here, it's going to go down towards this vertical asymptote, and then it's going to cross the oblique asymptote and go up to this one here. Now on the ends, so like if we put in x equals 3, notice 3 cubed minus 1 over 3 squared minus 4. That'll give us 26 over 5. So that's about 5 1/5. So 1, 2, 3, 4, 5 1/5. So that's right there. So notice the asymptotes will guide us here. And then on this side, if we put in negative 3, so negative 3 cubed minus 1 over negative 3 squared minus 4. So we get negative 27 minus 1, which is negative 28, over 5, which is negative 5 3/5. So we go down 1, 2, 3, 4, 5, and 3/5 is right there. So then we're going to go down towards the asymptote here and towards the oblique there. And notice on the x-axis, our domain is all filled in except for -2 and +2. All right. So I hope you enjoyed the video and you have a good weekend, and